Hello, I'm Dr. Gajanan. Today, we're going to see the concepts in object-oriented programming. So, the concept like class, object, inheritance, abstraction, encapsulation, and polymorphism. These are the important concepts in object-oriented programming. So, one by one, we'll see each one. When we are talking about class and the object, a class can also be defined as a blueprint from which you can create an individual object. So, class doesn't consume any space. That means the building block of object-oriented programming languages that leads to object-oriented programming is nothing but a class. It is a user-defined data type which holds its own data members and member functions or member methods, which can be accessed and used by creating an instance of that particular class. So you can say class is like a blueprint for an object. When you are talking about object in short is nothing but instance of particular class. So any entity that has state and behavior is known as object, right? So when we are saying animal, so animal is nothing but your class, and say dog, that is the object of that particular class animal. Another example you can consider fruit. So fruit is nothing but the class name, and the object with respect to this particular fruit class, they are apple, banana, mango. These are nothing but the object with respect to the class fruit. So you can say object is an instance of a class. Objects are basic runtime entities in object-oriented programming. So in C++, the class variables are called object. So using object, we can access the member variable and member function of a class. Object represent a person, place, or any item that a program handles accordingly. So this class and object, these are very important concept in the object-oriented programming language like C++ and the Java. So here we talk with respect to Java. So a class in Java is a set of objects which shares common characteristics, behavior, and common properties or attributes. So it is user-defined blueprint or prototype from which objects are created. For example, you can say student is an object. So and say I'm saying Ravi. So Ravi, student is a class, and Ravi is the object for the class student. There are certain properties associated with these Java classes. Like first, class is not a real world entity. It is just a template or blueprint or prototype from which objects are created. Class doesn't, they are not going to occupy the memory. Then class is a group of variables of different data types and group of methods. So class in Java can contain data member, method, constructors, nested class, and the interfaces. Then come to the Java object. In, an object in Java is a basic unit of object-oriented programming and represent a real-life entities. These particular objects consist of three things like state of an object, behavior of an object, and identity of the object. So when I'm saying say state, it represented by attributes of an object. It also reflects the properties of that particular object. When I'm saying behavior, it represents by methods of an object. It also reflects the response of an object with other objects. And third important part that is associated with the object is identity of that particular object. So it is a unique name to an object and enables one object to interact with the other object. For example, you can say object dog with respect to say class animal. So object dog is there. So what is the identity? Identity is the name of that particular dog. Right? So what your name to you give that particular dog, that is the identity. What is the state of that particular dog? So you can say its color, age, and breed. These are nothing but the state of that particular attribute. And what is the behavior of that particular dog? Where barking or bark, sleep, or eating, something like this. So these are nothing but the three important things associated with object: identity, state, and the behavior. Now we'll see a few Java classes and object examples here. Right? So here just see how to focus on that particular class. Right? So you are supposed to create a class using the keyword class. Right? So generally you can have an example say public class main. So this class is nothing but keyword which indicates that this main is the class and you are specifying certain attributes inside it. Then how to create an object with respect to a particular class, that example we'll see. Now here just see the class name is there with attribute x is equal to 5, and this is the public static void main from where the execution of your Java program starts. So for this particular main class, we are going to create the object myObj is equal to new main. So this statement creates the object of class main, and using this particular object we're going to access the attribute x. So we are using system.out.println, that is the syntax that you are using to print something, right? So that my obj.x, that means it is supposed to print this particular value of with respect to the x, that means it is going to print the 5. You can have multiple objects, right? That means for this particular class main, so you are having my obj1, then my obj2, right? So my obj1, my obj2, these are two different classes for the same. These are two different objects for the class main. Now this main is different than the main where m is small. So that just yes, this main is different than this main. So this can become a class, a normal class. And for these two objects, you are displaying the values accordingly. So same value you are going to display for the x for object my obj1 as well as my obj2. So you can use multiple classes in the Java, right? So, this is main.java, so public class main. This is one class. This is a second.java class. Where class second. Second is the name of the class. Inside the second class, we are specifying the main function from which, or main method from which the execution of your program will start. So you are creating the object of this particular class my obj, and of this particular main class, and then you are printing that particular class content of my obj.x, right? So these are certain compilation command through command prompt, say java c main.java, then java c second.java. Through the, you can say that command prompt you can compile this, and then you can run using java.second. So you will run that particular program. So it is going to print the file for you. Now we'll see how to deal with the class method inside a class. So same, you are having the class main, and here you are specifying the static void my method. So my method is the method which is the static, and you are printing something inside that particular method. From the main function where your execution of your program begins, you are just calling my method. So when you are calling this my method, it will print the hello world for you. Here just one thing that you are supposed to observe, that without using object, you call the my method from the class main. Why this is possible? Because that method is a static method. If it is not static, if it is public, you are supposed to use the object of that particular class. Just that's what I just explained. Static versus the public. So when the method is static, which means that it can be accessed without creating an object of the class. Unlike public method, which can only be accessed by the object. This thing you are supposed to remember. Just see here, public class main is there. Then you are having static void my static method. You're printing something inside that method. Then you are having a public void my method. So this is the public method. You're printing something inside that particular method. And from the main method, you're calling my static method. Right? So it will call the static method this, and then you have created the object of the main class of this particular class, that is my obj. And then if you want to call this public method, you are supposed to use the object of the class main to call this particular my public method. So that's what we are doing, my obj dot my public method. So it will going to call the public method on the object. Now how to access methods with an object, right? So you just say example, create a car object named my car. So you are supposed to call the full total and the speed methods on the my car object. Will run the program accordingly. So you just see public class main. Here you are specifying the full throttle method. So you are printing inside that method that the car is going as fast as it can. Then public method we are calling with some parameter, say max speed. So you are printing the max speed. Then we are having public static void main function. So here we are creating the my car, that is the object of this particular class main. Then we are calling my car dot full throttle. My car dot full throttle. So it will call this particular full throttle method. It is going to print the car is going to pass as it can first. And then We are calling the myCar.speed 200, right? So this 200 is the parameter that we are passing to the speed method. It will print the speed as the max speed is 200. So both public methods are there, and one is without parameter, another is with parameter that we are seeing here. Now the next important concept in the object-oriented programming language that is nothing but the concept of inheritance. Concept of inheritance. So inheritance is one of the basic concepts in OP in which one object acquires the properties and behavior of the parent object. Okay? So it's creating a parent-child relationship between two classes. It offers robust and natural mechanism for organizing and structure the software. Now, in inheritance, new data types like classes can be defined as extensions to previously defined types. Parent class, that is also termed as a superclass or base class. Child class is also called a subclass. Right? So subclass inherits properties from the parent class. So this is one of the important point in this particular inheritance. Then when we are talking about inheritance, inheritance supports you can say that different types like single inheritance. That means different types of inheritances are there like single inheritance, multi-level inheritance, hierarchical inheritance, multiple inheritance, and hybrid inheritance. So when you are talking about the single inheritance, so class B is inherited from class A. That is a direct inheritance from the parent to child, single inheritance. Multi-level, you are having the grandparent class, parent class, and the child class, right? So in this particular sequence of, you can say, derivation of properties from the grandparent to say child class to parent class is the multi-level kind of inheritance. Hierarchical, you are having a single say parent inheriting each property to multiple child classes. When you are saying multiple inheritance, where you are having two different classes, that means two parent classes. These two parent classes are having a single child, so the child can acquire the properties of two different parents. That is called the multiple type of inheritance. And the hybrid inheritance, you are having combination of single, multi-level, like this. So that is nothing but a hybrid type of inheritance. So these are different prominent types of inheritance. Now, how you can say that a class can extend only one class, however it can implement any number of interfaces, and the interface can extend more than one interfaces, right? So this particular, you can say that a combination is there. If your parent is class and child is also class, then you are supposed to use the extend type of keyword. That means if this is parent class A, this is child class B, so they can say that in Java language class B extend class A. So extend keyword we are using if parent and child are both are classes. If parent is interface and child is also interface, so in that particular case, we are supposed to use the keyword extends. So in interface is a purely, you can say that abstract class that we'll see later the concept of interface. Then keyword, the extent that you are supposed to use for both parent and child are interfaces. And if your parent is interface and child is class, so in that particular case, you are supposed to use the keyword implement. That means class implements the interface. Suppose this is interface A and class B. So class B implements interface A. So that sort of syntax you are supposed to use in this particular fashion. Now, when we are talking about this particular concept of inheritance, what is the advantage of using inheritance? The striking advantage of inheritance is nothing but the concept of reusability. Okay? Inheritance supports the concept of reusability. That is, when we want to create a new class and there is already a class that includes some of the code that we want, we can derive our new class from the existing class. So by doing this, we are reusing the fields and methods of the existing class. So that is one of the striking advantage of the concept of inheritance. We'll just have a look of, you can say that we'll look at some examples on inheritance. Say class vehicle is there, and we are having another class car. So car is a vehicle. So that is a type of relationship exists between these two classes. So we can have concept of inheritance in place. So class vehicle is having certain attributes and methods. So protected string brand is equal to 4. That is the vehicle attributes, and method is honk. That method we are using. So when you are saying this protected, this is nothing but the access specifier. So in object-oriented programming in Java, we are having public, default, private, and the protected type of public specifiers. Uh, then we're going to implement the inheritance. So class car extends vehicle. So this extend means that we are using the concept of inheritance. So class car extends vehicle. So this particular car is having its own attribute like model name, and then we are using the main function inside the car, that is the derived class. We are using the main method inside the derived class car. We are creating the instance of the car object, that means the derived or child class, that is the car class here in our case. Car, my car is equal to new car. So my car object is created here. And then from this my car, we are calling the method of this particular parent class vehicle, that is honk method we are going to call. So my car dot honk, so it will call this particular function of the parent class, because we are not using any function honk in the derived class. So through the inheritance, it is possible to call the parent class function from the derived class object. And again, we are using the same micro object to print the model name of that particular car, which we are specifying in the derived class. So in this particular fashion, inheritance can be used. There are certain advantages of inheritance like code reusability. Code reusability is, as I told you, that the child class inherits all instance members of the parent class. Again, you have more flexibility to change the code. So changing code in place is enough whenever required. Then you can use polymers, that is method overriding requires is a type of relationship. So that concept of method overriding, which is a part of your runtime polymorphism, that also have uh, taking advantage of this particular concept of inheritance to implement is a type of relationship. Now examples with respect to the single inheritance and other types of inheritance that we can see. So class animal is there, and class dot extends animal. The previous example is also example of single inheritance. That means that car is directly inherited from the vehicle, single inheritance. Here you can see that this animal class and dog class is inherited from the animal class. So it's a kind of single inheritance. Multi-level inheritance, so you are having the grandparent, that is the class animal, then you are having class dog extend from the animal, and finally what you are doing, class baby dog extend from this parent class. So this is your grandparent class, this is the parent class, and this is the child class, and you are creating the object of the child class, and through this particular object of the child class, you are accessing the methods of the grandparent class, parent class, and the child class. That is a multi-level type of inheritance. Hierarchical inheritance also is there, that is class animal is there. So class dog extends animal and class cat extends animal. So two child classes of the single parent. So that concept is hierarchical inheritance. Multiple inheritance, somehow Java is not supporting the concept of multiple inheritance. So when we are trying to do this in Java, class A, class B, two different parent, class A is one, class B is another separate class, and class C is supposed to be a child class which extends from two different parents A and B. And when in the main side main, we are going to create the object of this child class C as obj is equal to new C, and we are going to access the obj dot message. Which message, message method would be enough? That is the problem here. So it will go the compile time error. So multiple inheritance is directly not possible in Java. How that is possible, that we'll see in the conjugative concept. We are supposed to use the concept of inheritance accordingly to use the, implement the multiple inheritance in Java. The next comes the important concept of abstraction. So data abstraction is one of the most essential and important feature of object-oriented programming. Abstraction means displaying only essential information and hiding the details. The data abstraction refers to providing only essential information about the data to the outside world, hiding the background details or the implementation details. So this is nothing but the concept associated with this particular abstraction. Now consider here, you can say that example here. Suppose shape is the class, you are supposed to calculate the area, you have to display it. So rectangle is a kind of shape, circle is a shape, and triangle is a shape. So in this particular case, you are not disclosing all the information in the shape class. As per need of that particular, you can say that other classes, which is a kind of a rectangular shape, they are specifying that implementation in the rectangle, that is width into length, that attributes you are using to calculate that. For circle, you are using one attribute. For implementation, you are providing here about that particular calculation of area method. So For example, if I to take one example, in real time example of you can say abstraction, like a man driving a car. The man only knows that pressing the accelerator will increase the speed of the car or applying brakes will stop the car. But he does not know about how on pressing accelerator the speed actually increasing, isn't it? He does not know about the inner mechanism of the car or the implementation of accelerator, brakes, or any other part in the car. This is what abstraction is. Right? So I think you got the concept now. Now abstraction can be achieved with either by abstract classes or the interface. So when you are using abstract classes, it is 0 to 100% of abstraction. When you are using this interfaces, 100% you can say that abstraction you are implementing there. So when you are using abstract keyword is a non-access modifier used for classes and the methods. So abstract class means what abstract class doesn't have its own instance. Abstract method can only be used in abstract classes only and it does not have a body. The body is provided by the subclasses or the inherited classes like the here. You can make this calculated as abstract and implementation you can provide in the rectangle, circle or the triangle classes. Now, when do we want to mark a class as abstract? First, to force subclasses to implement the abstract method, in that particular case, you can use abstraction. To stop having actual objects of that particular class, we can use for the concept of abstract class. To keep having a class references, then to retain common class code. So that is nothing but the scenarios where we can mark a class as an abstract. Now, that means abstraction using classes, we can implement abstraction for this OOP language using classes. The class helps us to group data members and member function using available access specifier. Further, a class can decide which data member will be visible to the outside world and which is not. Now, there is a concept of the abstract data type. That is the class that has defined set of operations and values accordingly. So, such type of abstraction level is possible. Now, when you are talking about abstract class, so say it's about abstract class can have both abstract and the regular method. So abstract class animal. So this abstract keyword is there. Animal is the abstract class where you cannot create a direct instance of that particular. Public abstract void animal sound we are specifying. That is the abstract method. This sleep is the normal method. So for this particular example, it is not possible to create an object of the animal class directly. So when you are saying animal semi or which is the animal, it will going to give an error, right? So to access this abstract class, it must be inherited from the another class. That is one of the important condition here. You can see the example animal, sound and sleep. These two, one is the abstract method, one is the normal method inside abstract class. So say class P extends animal, and here for the animal sound, which is the abstract method here in the derived class, you are specifying the body of that particular method. And then you are creating inside the main object of the peak class is equal to new peak. And when you say mypeak.animal sound, it will going to execute this particular animal sound method from the derived class. And when you say peak.sleep, sleep is a normal function which will be executed from the abstract class animal. There are a lot of examples you can consider on this particular abstraction. Now next important concept is the concept of encapsulation. So encapsulation is for the detailed implementation of a component which can be hidden from rest of the system. So encapsulation means binding of data and method together in a single entity called class. So it's wrapping up your data and methods together, that is called as the concept of encapsulation. Right. So in object-oriented programming concept, the variables of a class are always hidden from other classes. It can only be accessed using the methods of their current class. Now, for example, in a school, a student cannot exist without a class. Okay. So variables and methods, that is wrapping up your variables and methods together, that is called as the encapsulation. So encapsulation is to make sure the sensitive data is hidden from the user. So to achieve encapsulation, you must declare class variables and attributes as a private, provide public get and set method to access and update the values of the private variables accordingly. So why encapsulation is required? So better control of a class attributes and methods, that is possible through encapsulation. Class attribute can be made read only or write only as per the need using get and set method. To provide a flexibility, the programmer can change one part of the code without affecting the other parts. Encapsulation is useful and it will going to provide the enhanced security to your code. So these are certain examples of say album class and stockkeeper class without encapsulation and the with encapsulation, right? So here this plus and minus this you can see scope is changed accordingly from you can say that public to private. So it will going to provide the encapsulation accordingly. The next important concept in the object-oriented programming is the polymorphism, concept of polymorphism. So polymorphism refers to, in general, you can say one name, multiple forms. That is nothing but polymorphism. So polymorphism means many structures. In short, polymorphism is the ability to take more than one form and refer to an operation exhibiting different behavior in different instances or situations. The behavior depends on the type of data used in the operation. So it plays an important role in allowing objects with a different internal structure to share the same external interface. So without polymorphism, one has to create separate modules named for each and every method. So for example, the method, say you are having some method, say fan. So in polymorphism, you can have a single parameter for the fan. Then one is having two parameters. So that will become your one function can be used for two different purposes, right? So that is nothing but the concept of polymorphism. So Java supports function overloading, but Java doesn't support operator overloading. That you are supposed to understand here, which is part of the polymorphism, right? So polymorphism in Java, that is a static polymorphism and the dynamic polymorphism. Static polymorphism, which is also early binding sort of thing, where method overloading is a part of the polymorphism. When you are talking about dynamic polymorphism, it's a runtime polymorphism, or you can say that late binding sort of concept applicable. Method overriding is the example of this particular for dynamic polymorphism achieved to the method overriding. Remember that method overloading is applicable in Java, but in case of C++ language, operator overloading is also a part of this particular static polymorphism, where operator overloading is not applicable in case of this particular Java. Now, just see, you can say that concept of method overloading in short. Method overloading in Java is also known as the compile time polymorphism or static polymorphism or early binding. In method overloading, compared to the parent argument, the child argument will get the highest priority, right? So there are two ways to you can say that for this particular method overloading, you can have a same method name, but there is different signature, right? So there is the you can say signature of the single method can differ by number of input parameters or type of the input parameter or mixture of the both. So accordingly, the method overloading can be achieved. So it can be achieved through two ways, by changing the number of arguments or by changing the data type. So just see here public class sum, that is nothing but you can see the class name sum, where you are having public integer sums, right? So here constructor, that is again part of, you can say that sort of method. So two parameters are there. Yes, sum is the method and that is belong to constructor, that constructor is name same as that of the class name. So three parameters. So this you can say that method overloading, where you are calling the method to the object of the class sum as s dot sum with two parameter, s dot sum with three parameters. The same method get overloaded. So here method overloading is changing number of arguments. As I told you, class say adder is there. Static int add two methods and static int add two parameters. Here two parameters for add method, same method name add but three parameters. So this concept itself indicate that this is the you can say that clear cut example of method overloading. So here in some test overloading class you are writing main method and you are calling this particular add function to this particular adder class. So as these are the static, you can say that methods, you can directly in class name call it adder.add with two parameters, get three parameters. So your output is generated accordingly 22 and 33 if you uh, after execution of this statement. So this is nothing method overloading. Now, by method overloading is not possible by changing the return type of the method only. Now here just see, in Java method overloading is not possible by changing the return type of method only because of ambiguity. Now see here class adder, here you are in static int add and two variables, here static double add and again here two variables. Here your this particular type is changing to double, but parameters remain same. And when you are calling this particular adder dot add with two parameters, so which add method overloaded method you are supposed to call. It is nothing but the ambiguity. So it will use the compile time error accordingly. Now, method overriding in Java. So I will just short overview about the method overriding. Method overriding is it is possible. It is going to override the method which you are declared in the parent class, that you are going to override in the child or the derived class. That is method overriding. It's the concept associated with the runtime polymorphism. Now, just in short, how you can say that this method overriding will happen here. Let's see, void run in the vehicle is the base class. Your run method you are specifying public bike extend vehicle, and then you are saying bike obj and new bike. So when you say obj dot run, it will call your, you can say that this method from the parent class. The problem is that we have to provide a specific implementation of run method in subclass. That is why we use method overloading. Suppose bike, how bike will run, how car will run. So if you want to specify such type of specific implementation, you have to go for the method overriding. For example, same vehicle is the class, run is the method. Now class bike to extend vehicle. Now here you are specifying again the different implementation of this run method, which is already there in the parent class, but its implementation is different here. And when you are creating bike to object of this particular bike to class, and when obj.run, it will call the derived class run method. So this is the short example of this particular method overriding in Java. There are a lot of, you can say, examples in this particular thing. In short, now we'll see a few points related to, can we override the static method? No, we cannot override this particular static method. It can go by runtime polymorphism. Why we cannot override static method? It is because the static method is bound with the class, whereas instance method is bound with an object. So static belong to the class area and instance belong to the heap area. Can we override the Java main method? No, because the main method is a static method. Now we'll see some differentiating factors between method overloading and method overloading. Method overloading is used to increase the readability of the program. Method overriding is used to provide the specific implementation of the method that is already provided by the superclass. Method overloading is performed within the class. Method overriding occurs in two classes. That is a type of inheritance or relationship occurs. In case of method overloading, parameter must be different. In case of method overriding, parameter must be same. Method overloading is the example of compile type polymorphism. Method overriding is the example of runtime polymorphism. In Java, method overloading can be performed by changing return type of the method only. Return type can be same or different in method overloading, but you must have to change the parameters accordingly. Return type in case of method overriding, return type must be same or covariant in method overriding. So that's all in this today's session. Thank you.